Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem remove k digits. This is a medium level question and it's the problem of the day on Geeks for Geeks today. The company tags of this question are Microsoft and the topic tags are stack and data structures. Even by this topic tag, you would have got the hint that yes, you need to use stack for this particular question. And let us go through this question now. Given a non-negative integer is represented as a string, okay? It's not an int, it's represented as a string. Remove k digits from the number so that the new number is the smallest possible. So you're given a freedom to remove k digits, exactly k digits from that number. So after removal of that k digits, the resultant number should be the smallest possible, okay? So the given num does not contain any leading zeros. So you need not worry about this, that you might be thinking like you might have zeros at the beginning of the string. No, there is no string like that, okay? So these are these examples given, and expected time complexity is O of length of string, and auxiliary space is O of length of string, and these are the constants, and this is the same solution that we'll be following. Like our solution also will be having the same time and space complexity, and as far as my knowledge is concerned, I think that is the most optimal one, okay? So let us now go through the examples first. So in this particular example 1, so 149811, so that is a string that has been given to us, and k is equal to 3. So k equal to 3, in the sense there the freedom for us is to remove 3 digits. So if we can remove 4, 9 and 8, what would be the resultant string? It would be 111, right? So that is the output. I hope you people have understood. And if you're thinking like to remove some other characters or some other digits, like if you would remove 981, what would be the result? 141, right? Is that smaller than 111? No. So whatever the three digits that you're thinking to remove, so thing is, it need not be contiguous. It's need not like you remove like a subarray or substring. It's not mandatory. You can pick any three digits randomly and remove them. So whatever combination of three digits you try, 111 is the least possible resultant you could get. So that is the thing here. And similarly in this case as well, if you can actually see example 2, k equal to 3, so they have removed this k equal to 3, in the sense three digits they have removed. So this one and this one and this one. So once you remove that, what would be the resultant? 0021. And because leading zeros would not be counted, so the overall answer is equal to 21. I hope you people have understood that. So from this this example, we can understand that yes, they are not counting the leading zeros in the output, right? They're not counting the leading zeros in the output. So it's our duty to actually cut off these zeros from the last answer that you're going to form, okay? So that is our duty. After you frame the last answer, it is our responsibility to cut off these leading zeros if there are any, okay? So I hope you people have understood this particular thing. And now let us frame the approach, okay? So starting with the brute force approach, okay? Starting with the brute force approach. So what would you do? What is your basic ideology? So let us assume I have a number like this, 6974, okay? I have a number like this, okay? Or 6947, that is fine. 6947, anything is fine, just like that. So 6947. Now the same task has been given to you. Right now k equal to 2, so you are given a freedom to remove k equal to 2. So what are the first choice that you have? Like there are four choices according to me. I think you are also thinking in the same way. There are four choices. What are the four choices I'm thinking about? So I'm thinking like, what if I remove 6? Okay, what if I remove 6? Then what are the digits I'll be remained with? 947, and I need to remove one more digit because I've already removed minus 6, okay? 6 I've removed. And what if I remove 9 instead of 6? So if I do this, I'll be having 647. So now also I still need to remove one more digit, because you in total you need to remove two digits, because now you are removing one digit each. So still you have one more digit to remove in this particular line. So now what if I remove 4? Then I'll be having 697. What if I remove 7? I'll be having 694, right? Now again, three choices now again for each and everything. What are those three choices coming in this particular fashion? So this has three more branches. So what are those three choices that you can take? Either I can remove 9. In that case, I'll be having 47. Either I'll be removing 4. In that case, I'll be having 97. Either I'll be removing 7. In that case, I'll be having 94. Okay. So again, three cases again here. So what are those three cases? Either I'll be removing 6, then I'll be having 47. Either I'll be removing 4, then I'll be having 67. Either I'll be removing 7. So in that case, I'll be having 64. Okay. So again, come to this particular thing. Okay. Again, three branches here. So I'll be removing 6. In that case, I'll be getting 97. If I remove minus like 9, I'll be having 67. If I remove 7, I'll be having 69. Okay. And finally, 3 branches here itself. I'm explaining in a very depth manner so that there'll be no confusion. So if I remove 6, I'll be having 94. If I remove 9, I'll be having 64. If I remove 4, I'll be having 69. So these are the end results. In this case, you have no more digits to remove. You have removed all the digits that you actually needed to remove. So what is the least possible among all these numbers? So 47 we have the least. I don't think there is any other number that's least than that. So answer would be actually equal to 47. Okay, this would be the answer. So what is the brute force that you're doing? Each number, okay, each number has two choices. Either it can be removed or just leave it and move to the next index and check if it can be removed. So these are the two options available for each and every number. So basically we are doing like 2 power k, because 2 power first one and 2 power like you can actually see, right, for like this one has given 4 outcomes and each of them has is giving you 3 more. So basically 4 into 3 is equal to 12, right? So here we have 4 outcomes and each of them is giving you 3 3 3 3. So it's basically exponential. It's being exponential, right? So 2 power k, because each and everything has a 2 options, so you can directly assume it's like basically of the order 2 power k. Great. So this is the brute force approach, right? This is the perfect brute force approach. But what is the optimal now? So if you want a code for this particular thing, let me know. I'll even send that code in the description. Okay, I mean sorry, in the comment section. So what is the optimal code now? What is the optimal code? So for decoding this optimal approach, all I used is my basic common sense and the topic tags that they have mentioned is tag. So immediately once I realized that this thing is happening, like I'll explain you that that is happening, I got this thing like, yes, stack is the perfect data structure to use. But what is the thing that I've did to decode that? Okay, so I have first manually checked some examples. So you just take this example itself, 149811. Okay, 149811. Check properly. Okay, check properly. I was like first evaluating what is the impact. Okay, what is the impact created if I remove any number? Let us assume I'm trying to remove 9. Okay, I'm trying to remove 9. What happens if I try to remove 9? So 4 will come here, 1 will come here, isn't it? So the number will be like here right now it is 1 lakh. Okay, 1 lakh 40,000 9 yeah 49,000, yeah, 49,900 811. So this is the number, right? 811. This is the number, 1,49,811. Let us assume, okay, let us assume I am removing this 9. Okay, I'm removing this 9. What happens if I remove this 9? This number transforms to 14811, isn't it? 14811. This is what the number transforms to if I remove 9. Once I remove 9, what is the number right now? What is the value of this number? This number is 14,811. 811. Is 811, did this change? Did this affect? Did this get any effect? No, 811 remained the same, right? 811 remained the same. But the contribution from 14, here it was 1,40,000, right? Here it was 1,40,000. But now here it is 14,000, isn't it? 14,000. So how much there is a reduction? By 10 times. By 10 times, isn't it? So if you just remove this number and shuffle these things, you will be having an effect of 10 times. Okay. Or if you say, let us now you are saying that, okay, instead of removing 9, I'll remove 8. Okay, instead of removing 9, I'll remove 8. So in that case, what would be the number? 14911, right? So even in this case also, what is happening? So 14, which is previously having 1,40,000 as the value, now it will have the 14,000 as the value, right? There is no change. There is no effect of or impact. Like there is no particular change in impact. Even if you remove 9, the 14 is being affected in the same manner as you affect 8, like as you remove 8, right? So even if 8 gets removed, 14 will be affected, like 1,40,000 to 14,000 you will get. So even if 9 is removed, from 1,40,000 to 14,000 only itself you will get. Okay, so there is no practical impact of the numbers. But at the end of the day, what are you getting? The number here, you are getting 14811. Here 14911. What is the thing that you will choose? 14811, because this is least. This is least, right? This is least compared to 14911. 14811 is least, so I'll be choosing that. Okay, I'll be choosing that. But to the effect created, the impact created is same in both the cases. Either you remove 9 or 8, but we'll be going with that number that has the least value. Okay, least value. So long story short, if I put this in 2-3 words, that means go with the numbers that are having less value. Okay, that is the story, that is the conclusion. Okay, so go with the numbers that are having less value. So in this case, if you are actually fighting for this position, so 1 4 9 8 1 1, so if you're actually fighting for this position, so I am thinking of to remove either 9 or 8, either 9 or 8, any of these two I'll be removing. So now I need to come to a conclusion what I need to remove. So without any hesitation, I'll be removing 9 and I'll be putting 8 here. So the final result would be 14811. I hope you people have understood. Because the impact created is same, I have no formalities or complications created by any number that I'm going to remove. Only thing at the end of the day, I want a smallest number. So I'll be going with that number that has less value, isn't it? So for if I'm fighting for this position, like I'll be removing one position and there'll be only one thing. So if there is a road like this and there is a house, there are two houses, you need to remove one of the house to construct the road. And now I've given the condition that I'll be removing that house which has the highest value. So I'll be removing this one and I'll be putting this house here. That's it. Very easy, right? Same thing happening here. There is only one blank because one I need to remove. One only will be there. Now for that position, who is going to occupy? Either 9 is going to occupy or 8 is going to occupy. Without any hesitation, I'll say 8 is going to occupy because it has the least value. Because whatever number you want to remove, the impact is same. Okay, the impact is same. So you put the number that has the least value because that is what you want at the end of the day. And the end of the day, isn't it? I hope it's pretty clear for you people. Now comes the actual problem. Okay. Now, with what are you comparing? 9 and 8 I am comparing. Why am I comparing 9 and 8? What is the reason? I could have compared 9 and 4. Why am I comparing 9 and 8? So that starts from the initial. This fighting starts from like 9 says because you are this 4, okay, 1 4 9 8 1 1, right? So this 9 says, okay, why are you comparing with me with 8? Why don't you compare me with 4? Or why don't you compare 1 4? Why don't you compare 8 1? In that case 8 will be gone. Why are you showing partiality to me? This type of fighting is coming at this point. So this starts, okay, so for this to eradicate this fight or something, you need to follow this analogy from the start. Okay, from the start. So if there are like this many digits, okay, these many digits that your original string is. So if I'm putting some value x here, okay, if I'm putting some value x here, now if I'm trying to put some value y, so this will occupy x place. Okay, this y will occupy x place if y is actually less than x. Okay, if y is less than x or x is greater than y, both are the same. So if y is actually less than x, then y will actually occupy this position. If y is not greater than or not less than x, y will sit here. Okay, y will sit here. Y will sit here calmly, peacefully, so that if there is any other competitor comes with that, y is going to fight. Okay, so that is the analogy here. So here thing is, so if I put that in simple examples, so there's a string that you need to fill and there are two options, 9 or 1. So would you like to fill 1 or 9 here? Would you like to fill 1 or 9? I would go with 1. I would go with 1 because I want the least, smallest possible value. So I would not want 9 in my first bracket. I would want 1. Isn't it? That's very basic, simple thing, simple logic thing. Because you want the least possible. Why do you want to keep the largest number first and the smaller number next? So 1 9 is better than 9 1. Isn't it? That is very evident. According to the question, you want the least possible. So put 1 9 instead of 9 1. Why are you putting 9 1? Right? So this fight starts from here. That is the reason I'm saying. If x, okay, if I'm putting 1 here and now if I'm trying to insert 9 will not take 1's position because 9 is actually greater than greater than x. So 9 will sit at this point. So it will be like 1 9. So if there's any other competitor coming, let us assume 8 is coming now, 8 will replace 9. Okay, 8 will replace 9 because instead of 9 I can put 8, isn't it? That's very evident. So when I'm replacing it, I will decrease my k value because now I'm doing a replacement or taking off. I'm removing 9, I'm putting in 8. So this is where I'm doing the change. So I'm going to reduce k. So I'm going to do these things till my k will become 0. That is the logic. I hope you people have understood. Very, very easy thing. So if you want me to dry run this particular thing here, okay, so First one, so for these things like replacement and this comparing with the last character and all these things can be easily done using the help of stack. That is the reason stack has been mentioned. So if in the topic tag stack wouldn't have given, I would have taken 2 more minutes to come to that conclusion, but it's given, so I've immediately come to this conclusion that a stack can be used here. So take this example 149811. Okay, so take a stack initially. Okay, this is how a stack looks like. Fine. Now you're trying to fill this thing, you're trying to make a new string. So how are you going to do? So first thing what you'll be putting is, because now what is the k value? K value is actually equal to 3, right? K value equal to 3. So you'll be putting 1 year. Okay, you'll be putting 1 year, and also you'll put 1 year, right? Now you have this is done. Now this is done. Now come to 4. Now we are coming to 4. You see that 4 is actually greater than 1. So 4 will not occupy this position. 4 will calmly sit here. 4 will calmly sit here, and it will also go to the top of the stack. Okay, so 4 will calmly sit here. This is also done. Now coming to 9. 9 is actually greater than 4. So 9 will not occupy this position. Okay, because we always want the smallest to be in these positions. So this must be like this: smallest to largest. So this is how we want the thing to be, want the final result to be. So 9 will come here and sit calmly. It will not replace 4, because it does not have any right to replace 4, because 9 is larger than 4. So 9 have no rights. So 9 will go to the up of the stack. Now comes 8. Now comes the hero, asli hero. So now 8 says, bro, 9 bro, you should empty the space, because I am less than you. Okay, I have less value than you, so you must go away. I have a caste reservation here, so you must go away. So this fellow will go now. Okay, this 9 will go now. Okay, this fellow will be replaced, so we'll be having 8 here. So similarly also remove this 9 from the stack. Okay, 9 from the stack. Now you'll have 8 in the top. So this is gone. Now 1 comes. So every karma has a hit back, isn't it? So this 1 will say, 8 bro, you go now, because I am much more less than you. I'm much more smaller than you. So you please leave. So this fellow will be removed now, and you'll be having 1 year. Okay, you'll be having 1 year. But again, you see, if 8 is gone now, you still have 4. Again, this also will not be tolerated, because after doing 2 operations, what is the value of k you have? K you have is 1, because here this 8 replacement 1 k has been used. 1 to 8 replacement 1 k has been used. So two values have been 2 units, k is decreased. So still you have k equal to 1. So still you have a right. Still you have the caste reservation right. So this fellow will say 1 to 4, bro, you still live. I still have value of k to be there. So you can also live. I'll replace you. So in this case, this 4 will also be gone, and now you'll be having only 1 year. Okay, now you will be having only 1 year. So this is also gone. So finally you will be having 1 now. And now coming to this particular one, so 1 will say 1 is 1. So and there is no value of k also. After this replacement, k will be equal to 0. So 1 will be sitting here, and that's it, right? So add 1 to the top of the stack. Now put all these things into the some answer string. Okay, so 1 1 1. So that would be the answer, right? That is the final answer. So here, because all the digits are same, you're not reversing the thing, but in actual you need to reverse. Okay, you need to reverse. So then only you'll be getting the correct answer. This I'm leaving as a task to you people. Why am I actually trying to reverse? So take some other example, or you can even take example to dry run on it. You'll get a better clarity. Why are we reversing? Okay, that is very essential, right? Nor it's a wrong answer. It's that you must reverse, because on the stack you're putting the last things, but you want the first things to be in the right side. So that is the reason, left side. So that's the reason you need to reverse this thing. Okay, if you do not reverse, you will not be getting the exact number. So I hope you people have understood. So I do not want this video to be very lengthy. That's the reason I'm cutting off some unnecessary things. I'm giving you that way assignment for you people, or task to you people, right? So I hope you people have understood. So let us go to the code now. First I have taken this thing, simple thing, logic. If n equal to k means the number of digits you need to remove. So if actually n equal to k, that means all the digits you need to remove. So in that case, return 0. Now take a stack. So for int I equal to 0, first do not consider this. Directly push the stack dot push dot store dot push of s of I. This is the first digit that you'll push, and now you'll see the coming digit. Okay, if your previously digit stored digit is greater than the coming digit, if that is the case, replace that and decrease the value of k, because you are replacing, you must decrease the value of k. So until you will be doing the same this operation until and unless you have some value of k. So if you after this whole operation, after even inserting this, if you have still k's left, then you can start popping up the last top elements of the stack. And finally take a string answer variable, and till the stack gets empty, push that push back those top elements into your particular answer string, and then this goes on and finally reverse it. Okay, that is the important point. If you don't reverse it, you will not be getting a right answer. And this is like cutting off leading zeros. This operation is to cutting off leading zeros. Okay, cutting off leading zero. Finally you return 0 if the case is like answer is length empty or something like that. In that case return 0, or in case you can just return this. So this is a cutting off leading 0. Once you have something that is non-zero, return that particular substring starting from that particular index. Okay, so that's it guys. I hope you people have understood this. I've tried to explain grassroots level, explained each and everything, every small segment I've explained. So starting from the intuition till basic common points that we need to have in mind before solving this, and the idea that how I got to know that it's a stack, everything, right? So I hope it's clear. If there are any doubts, please feel free to comment in the comment section. Also the codes in C++, Java, Python are given in the GitHub repository. The links to them are also there in the description. Also, I've created a WhatsApp channel for posting off-campus internship and placement opportunities. You can even consider joining that particular channel. All right. So thank you guys for watching this video. Stay tuned.